Welcome to another session in our series of tutorials in R for data science, and in this session we're going to tackle data visualization. And in data visualization I'll be using the ggplot package. So R provides various ways in which we can perform visualization. That is, we can use the base R functions, we can use the ggplot function, we can use the plotly package, but in this session we are going to use the ggplot because it's one of the most elegant data visualization tools available. So we'll be using the tidyverse package. So we have to install it using the command install.packages, the tidyverse. So I've installed this, that's why I've commented this line. After installing, you have to load the package using the library command or require package. So in this data visualization session, we'll be looking at the scatter plot, that is visualizing two categorical variables. We'll be looking at bar plots or bar charts, that is visualizing that's discrete variables. We'll be looking at heat maps, that's visualizing two continuous variables. We'll also be looking at pie chart, that's visualizing one categorical variables. We'll also use box plot, that is visualizing the continuous variables. So let's start with the scatter plots. And when we are using scatter plots basically are ideal for visualizing, or they are used to visualize two continuous variables. So one continuous variable on the x-axis and one continuous variable on the y-axis. So this is a data set called empty cars. So we'll be using this data set. You can type question mark empty cars, and let's run this first. And here it is. This empty cars is a data set of motor trends in the US in the 1970s. So as you can see, these are the 11 variables. These are the 11 columns that are variable. So as you can see, miles per gallon, COIL, displacement, gross horsepower, until the carburetors. You can use the head command to see the first few variables, or the first few columns, the first few rows. The first few rows, the first 6 rows of the data set. And here it is. You can use the glimpse or the structure command to see the structure of the data set. And here it is. You can see this one is a double. All the variables or the columns here are classified as doubles, or they are numeric. And in this case, that's not true. The car carburetor is not double. The gear is not double. The AM, that's the transmission type. It is not numeric, or it's not double. The V is not double. The CYL is not double. These are factors. These are factors. So we want to change them into factors. So we'll use this command as.factor to change them into factor, or they are categorical variables. So we want to change them into categories. So I'm saying empty cars, then $CYL. So I want to change this CYL into a factor. So it's like I want to change this CYL, the CYL column in the empty cars data set. I want to change it into a factor and rename it as empty cars CYL. So basically I want to change the CYL column into a factor. So I run that. I also run that. I also change the AM. I also change the car carburetor. I also change the gear. If I look, let's see this structure of this data set again. Empty cars using the glimpse command, and you can see they have been changed into factors. So let's use now the scatter plot command, or the ggplot. So we will be using the ggplot. So because we have loaded the tidyverse package, there's no need for us to load this package again. So we just call the function. So the function is ggplot. So let's just run this function called ggplot. So the first argument in ggplot is the data set that we're using. So we are using the data set called empty cast. So I'm saying ggplot and my data set is empty cast. Let's just run this and let's see what type of plot will be plotted here. So basically that one, this will plot an empty graph or an empty plot. So this one will not plot anything. So now let's provide the the value that will be on the x-axis and the value that will be on the y-axis. So I'm saying ggplot. Still the data we're using is empty cast. I'm defining my mappings whereby I'm using the aesthetics command, whereby on the x-axis I want miles per gallon to be on the x-axis, and on the y-axis I want the displacement to be on the x-axis. And then I'm adding, so we are using plus geom point. So let's run this. And here it is. You can see there is this scatter plot. You can as well zoom this, zoom, and here it is. It has been zoomed. On the x-axis we have the miles per gallon. On the y-axis we have the displacement. So this is basically the scatter plot. For each value, for each miles per gallon, there is a corresponding displacement. So that is basically a simple scatter plot. And as you can see, there is a negative relationship between displacement and miles per gallon. Let's add some. We can add color to this. We can change the color of this scatter plot. We can also change the size of this scatter plot. We can also change the shape of these dots. We can use stars. We can use maybe squares, triangles. So I'm using still the function ggplot. The data is empty cars. I'm defining my mappings using the aesthetics. On the x-axis I want miles per gallon on the x-axis. On the y-axis the displacement. So I'm saying size is equals to am. So there is a variable called am in this data set. Here it is. It's called am, and it is a categorical variable where it has the value 0 and 1. It has the value 0 and 1. If you help command, here it is. The am is the transmission type. 0 is automatic, 1 is for manual. So I want the size. I want each variable here in am, that is 1 and 0, to have different size. So I'm saying size is equals to am. Let's just run this and see. Saying using size for discrete variable is not advised. So it has advised that here it is not advisable. So let's run it. So let's use a geom point again, and then our mapping. We are defining our mappings again. Aesthetics. Our color is equals to blue. I want to change this color to be blue. If I run this entire lines of code, and here it is, as you can see, the size has been changed. So yeah, size is based on am and our color is blue. So that's how you change the color and the size. You can as well change the shape. You can change the shape using in the aesthetic command. You can change the shape based on another categorical variable or categorical column. So there's a column called gear. So I want each gear, a car gear, to have its distinct shape. So I'm saying ggplot, the data still is empty cars. On the x-axis is miles per gallon, y is displacement, shape is gear. I also want the color to be maroon. And let's run this and see. And as you can see here, you can see this the gear has been mapped using different shapes. So that is how you can change the shape, size, and color. You can also add the x-axis, the y-axis, and the title. So I'm saying ggplot, the data is empty cast, my mappings, I'm defining my mappings. Then I'm saying plus geom point, then plus x label. So x label, this is the x label in quotes, y label is the y label also in quotes, and here is the gg title, the title of the plot now. And if I run this, you can see it has been here is the title, here is the y-axis, and here is the x-axis. Another way of visualizing your data is using facets. So facets basically you want to break your data set based on another categorical variable. For example, in this VS, I want to plot each VS on its own graph, so in such a way that this one will be is equals to VS1, and then adjacent to it VS is equals to 1 also should have its own scatter plot. So in that case I will use something called facet underscore wrap, and facet underscore wrap basically facets, or it breaks a scatter plot basing on a categorical variable. So here, for example, I want to break this data set or this graph based on car carburetor. So I'm saying ggplot, is the name of the data set. I'm defining my mappings, geom point, the x-axis, the y label, the title. I'm saying facet underscore grid, and I'm using this tilde operator. This is saying that I want to model this graph as a function of a car carburetor. So if I run this, you can see, and here it is. You can see this graph has been broken down basing on the car carburetor. So these are cars, these are of the cars with carburetor 1, and you can see the cars with Control Shift 6. You can see the cars with car carburetor 1 have a VS of 1, and the cars with car carburetor 3 actually have a VS equals to 0. So this is what facet underscore wrap does. So it breaks various variables. It breaks a certain scatter plot or certain graph into distinct or various graphs basing on one categorical variable. What facet underscore grid does is that it adds another variable, so in such a way that there will be two categorical variables. So it's like I've just copied and pasted this line of code, and here I've added gear as a function of car carburetor. So this graph will be broken down basing on car gear and car carburetor. And here it is, as you can see. This is the car carburetor 1, 2, 3, 4, 5, 6, and this is the car gear. So that is facet underscore grid. The second graph that we'll be looking at is the bar plot. So the bar plot is used for categorical variables in that it gives us the count per each categorical variable. So what help us plotting that or what is used to plot bar charts or bar graphs in ggplot is geom_bar. In that, in scatterplot we use geom_scatter, so here we'll be using geom_bar, and there are several geoms function that we'll be using in R. So if you want to see the several geoms, you can just type geom underscore, and you can see there's upline, area, bar, box plot, color, contour. There are several, so you can see each function how it can be used. So I'm saying head empty cast again, still the same data set. So I'm saying ggplot data is equals to empty cast, mapping is equals to aesthetic, x is cyl, and cyl was a categorical a variable, or it was a factor, and I'm saying geom plus geom_bar. Then let's run this and see. And here it is. Here is the bar plot for us, and you can see what bar plot does is that it takes the count of cyl of cast with cyl4 and it counts them and it plots a bar chart. It cyl6 and cyl8 and it plots them. So that's basically it performs a count. So I can use this function called empty cast, then I'm piping it. So what this pipe operator does is that it's like and then, so empty cast and then it groups it by cyl and it counts. So these are the cyl for this one, the count is 11, 6 the count is 7, and 8 the count is 14. So it's approximately 14 for here is 15. So that is bar chart. So you can add the title using gg title. You can use the gg title to add a title to your graph. So you can as well color bar chart using the color function, or you can use the fill color, but this color is not ideal. So let's run this. We are coloring it using the color command. Let's run that and see. So as you can see, it is not that appealing, but if we fill color it, so here I'm saying the ggplot, the data is still empty cast, I'm defining it as my x, and I want to fill it by vs. So I run this, and as you can see, it stacks it on top of each other. So what if I don't want this to be stacked on top of each other? I want this one to be adjacent to it. So that's where we use a positional adjustment. So I'm saying ggplot, the data is empty cast plus geom_bar. I'm defining my mappings, aesthetics, x is the cyl, and then I'm filling it. So I want to fill color by vs. Then I'm saying position is equals to dodge. What this function called position does is that it places the cars with each of the cars or the cyl adjacent to each other for in each categorical variable. Let's run that and see. And here it is, so adjacent to each other. The third visualization tool is the histogram. So what histogram is used for plotting one continuous variable, and it is used to check whether data set is normally distributed or not. So I'm saying ggplot, the data still is empty cast. I'm saying plus geom histogram. So I'm using geom histogram is used for plotting histogram. Then my x-axis is the displacement. I'm defining the bin width. I'm saying the bin width is 45. So let's run this function and see. And here it is. So it has plotted for us this histogram. So the bin width is just a matter of playing with the number. So basically this will give you the number of bins. You can change this one maybe to 20, and you can see what it does. See, it reduces it. So it has reduced the number of bins. So basically it's just a matter of playing with them. So return it to 45 and we run it. That is it. So instead of, if you want to plot for various or breaking down a histogram basing on a categorical variable, we use freq poly. So what freq poly does is that instead of plotting this histogram or in this format of bars, it will plot it in form of lines. So let's see this ggplot. The data is still empty because I'm saying plus geom freq poly mapping. X is still displacement. I want to color it by am, and I'm saying the bin which the bin width should be 45. Let's run this and see. As you can see, there are two plots here, one for am0 and one for am is equals to 1. So that is what freq poly does. Let's look at box plot. So box plot is used for plotting one categorical variable and one continuous variable. So I will use geom box plot to plot geom to plot box plot. So what a box plot shows us is that it shows 5 number summary. So basically this is how a basic box plot looks like. So it shows us 5 number summary, in that it shows the minimum, the first quartile. So basically this here is the minimum, this is the first quartile, this is the median, this is the third quartile, and this is the maximum. So it shows the 5 number summary. So you're using the box plot command or geom box plot. So see, I'm saying ggplot, the data is equals to empty cars, mapping is equals to aesthetics is equals to my y is displacement. So I want on my y-axis to I want to plot for me on the y-axis is the displacement. So it basically shows you the 5 number summary. That is the mean, that is the minimum, the first quartile, the median, the upper quartile, and the 95 or the maximum. And this box here from here up to here is what is called the interquartile range, the interquartile range. So basically that's getting deeper into statistics. So I'm creating another box plot here. I'm saying ggplot data is equals to empty cars x. On the x-axis I want the carburetors, on the y-axis I want displacement. I'm saying I want the color per each carburetor, and I'm using the function geom box plot. Let's run that and look at this now. This is beautiful. As you can see, this is the cars with carburetor 1, carburetor 2, carburetor 3, carburetor 4, carburetor 6, and carburetor 8. So it shows you this is the minimum, the first quartile, the median, and the upper quartile, and the maximum, that is the median. So what if I want to flip this code, in that I want the x-axis to be, I want to change this the coordinates, that is I want x-axis to be on the y-axis and y-axis to be on the x-axis. That's when I'll use this command called code underscore flip. So if I flip this coordinate, that's mean I'll be flipping the coordinates. Let's run that and see. And here it is. As you can see, the CYL has been plotted on the x-axis, on the y-axis, and displacement on the x-axis. And let's look at heat maps. And heat maps are used to visualize two continuous variables. So I'm creating, there's a data set called diamonds. You can type question mark diamonds. This data set comes with the ggplot function. So so it's prices of over 50,000 round cut diamonds. So that is the data set called diamonds. So you can as well look at the data set diamonds using the head command, head diamonds, head of diamonds. Let's run that and see. And it is the color, clarity, depth, table, price, x, y, and z, carat, cut. So I want to use the cut and the color. So I want to use this to visualize it. So I'm saying I'm creating a data set called D1. I'm saying diamonds, then I'm using the pipe operator. So the pipe operator is like it's and then I want to group it by cut and color. I want to group it by that. I want it to tally it, and after tallying it, to arrange it in descending order by the count of each color and each cut, and then I want to view it. So let's run this and see. As you can see, so the most abundant type is ideal, that the diamonds that are cut of ideal and color G, and the one that has the minimum number is the one that has fair and the color is G. So what if I want to visualize that? What should I use? That will be using that is the heat map. So I'm saying ggplot data is equals to D1, my mappings, aesthetics, X is cut, Y is the color, the fill, I want to fill color it by N. So fill it color, so by the number of each, or the count of each diamonds should be its color. And then I'm saying geom tile. So geom tile will help us create that is the the heat map. So if I run it up to here, let's run that, and here it is. So the most abundant type is this one, this color, and here it is, and the least is this one, which is slightly darker. So if this is not that appealing for me, I can use a scale fill gradient. I'm saying the low color should be white and the high color should be maroon. I can change this from maroon maybe to, let's change it to blue. Then I'm saying, let's run this up to here. And as you can see, this is the most abundant, and then this one is the least. Actually, this one is the least abundant. The fair is the least abundant. So I'm saying plus labs. I'm saying labs is also used to add a title. I'm saying title heat maps. Then subtitle is the subtitle that ideal and G are the most abundant. If I run that, you can see this is the title and this is the subtitle. And finally, let's look at the pie chart. I'm saying that there's data set diamonds. I'm saying data underscore 1 diamonds. I'm piping it to count. That is the cut. I want to arrange it in descending order and I want to view it. I run that. Let's view it. Let's add the pipe operator here. Control Shift M. So if I run this, and here it is. So I want to plot the percentage of all this. So I'm using the pie chart. So a pie chart, there is no geom that is specifically designed for that is for the pie chart. So we'll be using the geom bar or geom call plus code underscore polar. So I'm saying ggplot data is equals to data 1. That's the data we have created. Aesthetic x is the cut. Y is equals to n. N is the count of this diamond. This is what is here is the n. So I want to plot this the count, the percentage of ideal, the percentage of premium, percentage of very good, percentage of good, and percentage of fair. So let's run this. This is so we want to turn this into pie chart. So we'll be using geom call. So if I run this again, so I'm saying ggplot, the data is data 1, this is the x-axis, y is equals to n. I want to fill color it by cut, and I'm saying geom columns. So that's geom call. So we'll be using this geom call plus code polar to create that is to create a pie chart. So let's run this. Now let's so if we run this up to here, it will give us this. But if we add this code underscore polar, let's run this and see. And here it is. It has shown us something which mimics a pie chart. So we want to build this into a beautiful pie chart. So I'm saying ggplot. So I'm saying x here x is equals to cut, y is equals to n, fill is equals to cut, geom call, then code polar. I'm saying theta is equals to y. Let's run and see this. You can see it has created some circular around this pie chart, but what has made that is because we have said x is equals to cut. X is supposed to be empty, so saying x is equals to empty, then y is equals to n, fill is equals to cut, then geom color. So if I run this up to here, you can see, so it has actually created it's like it's a bar chart, but it has stacked it on top of each other, so that's one bar. So if I remove this, then I'm saying geom curl to change the color into black. I'm saying code polar, theta is equals to y, and then I'm saying theme void. Let's run that. And you can see now here is our pie chart. So I'm saying geom color is equals to black. So these so that you can separate this cut into fair good using the black, and theme void remove the background. That's the color background noise from this data set. So basically this is how you create a pie chart. So basically this is just an introduction to basic visualization. So and remember there is also plot ly, and there is also the basic r plot function. So meet you in the next lesson. Enjoy learning. Thank you.